Alright, moving on to adding and subtracting these things. So if you have noticed, these things are basically giant fractions. So you should know what you need before you can add and subtract. It's going to be a common denominator. So a couple different things. They call it a least common denominator. Having a least common denominator will make it the most simplified version. For example, if you look at this problem, they worked here. They factored out both denominators first, and noticed that both denominators already had an x minus 2. So if both denominators already have an x minus 2, you don't want to multiply both of them just by the other one. Okay, that's going to make it a lot more complicated. You could just multiply by the parts that are missing. For example, they multiplied this one by just the x plus 2 on top and bottom, and this one by the 2x plus 3 on top and bottom. That's going to help you find a more simplified function than if you did the whole thing and have to factor back out. So looking here at question number 1, after I just told you this, looking at these denominators, there's nothing to do to make those the same besides multiplying them by each other. Now I actually really hate this question, because if you paid real close attention, you could simplify them here at the beginning and then you hardly even have a rational function anymore. But we're going to leave them alone, and I'm going to say the only way I can make those the same is to turn both denominators into a 6xy. I make that happen by multiplying this one by the other side and this one by the 2y. So if I simplify out the tops, that gives me a negative 14xy squared plus a 12xy squared for this one over here. Now I know that that made both my denominators a 6xy, so I could go ahead and put all this over the 6xy. To be honest, usually I simplify the top first before I ever go back to the denominator, because I know what the denominator is going to be. Looking here, I could combine like terms since they are both xy squareds. This one would become a negative 2xy squared on top and a 6xy on bottom, which could simplify if you notice the x's cancel. This y cancels 1 here. 2 over 6 can both reduce to just negative y over 3. Like I said, that's not exactly the best question I could have given you. Moving on to the number 2, though, this one's a little better. Again, looking at the denominator, there's nothing I can do to make those the same besides just multiplying by the other one. I can't just add 2 or subtract 2 from this one and say, hey, then it'll magically become x minus 3. You can't do that. You have to multiply is the only way you can make them the same. So the only way I can multiply them and make them the same is to multiply them by each other again. So this one times x minus 3 on top and bottom. This one times x minus 1 on top and bottom. Now again, this is where I like to go ahead and say I already know my denominator is going to be an x minus 1 and an x minus 3. I leave that there and I just simplify my numerator. So coming over here doing some scratch work, I know that I have 2 times x minus 1 minus 1 times x minus 3. That's just the top parts right here, just kind of rewritten. I can distribute. If I distribute the 2, that's a 2x minus 2. If I distribute the negative 1, pay attention, that was a subtraction sign between those. It's a negative x plus 3. When I combine my like terms, 2x minus x is just an x. Negative 2 plus 3 is a plus 1. And I can't simplify that any further, so this is my answer. There is a slight possibility that sometimes you could simplify just a little bit more. This time that didn't happen. So looking here at question 3, this is an example where it helps to find that least common multiple. Okay, notice that both of these equations already have a c. So I don't want to multiply just this bottom by this side and this one by this side, because they both already have a c. Then you'd have a c squared by there. You don't need that. That wouldn't be the most simplified way to do that. So I could just multiply this by the parts it doesn't have, which is a 3b. And this part by what it doesn't have, which is a 5a. Okay. That, again, makes my denominator, I know, a 15abc. Simplifying my tops, this becomes a 20a squared. Again, there's a minus between there. 15 times 3 is 45b squared. Okay. There's not much you could do here, except I could factor. Looking at this, I could factor out a 5. That leaves me with a 4a squared minus a 9b squared, and that, you should know, actually factors also. So right now I have 5 times 2, that's a really bad 2, 2a plus 3b and 2a minus 3b. So you do want to factor it out if it can factor. It doesn't happen that often, but again, it might simplify the bottom. For example, here, 5 can cancel the 15, and this simplifies to be just 2a plus 3b times 2a minus 3b all over 3abc. Can't simplify anything else because remember it has to factor out of everything, and I haven't been able to take just an a out of everything. So here looking at question number 4, if you just multiplied these denominators by each other, it would be a terrible question. You'd have to FOIL some stuff out and it would be ugly. But if you factored this first, you would see that they both already have an x plus 2. All you have to do to make these the same is multiply this equation by 3 on top and bottom. Again, I know what that makes my denominator. That's just a 3 times an x plus 2. Again, I like to leave it factored out. When I do my numerators here, that's a 9 plus 4x plus 5. I can simplify that just a little bit. 9 plus 5 is 14. I could factor a 2 out of there, and you can if you want to. I can tell already that that's not going to simplify it any, so I'm just going to leave it. Same thing when you get here. Look at how terrible this would be. If you just multiplied these by each other, you would have to distribute all of this to all of that. And that's a terrible, terrible, terrible thing to have to do. So you should just factor the bottom and top, or the bottom first. You can try to factor the top first. Sometimes that'll simplify. And actually, this one does. So look what happens here. I'm going to simplify this one. These are stupid questions sometimes. If you look, I could have factored a 3 out of here. And then this x plus 1 and this x plus 1 can cancel out. Over here, I have this x minus 1 and this x minus 1 can cancel out. So if I had seen that, that would save me a lot of time because now I already have common denominators. Notice that for this one right here, when you cancel that out, that's just a 1. That's all that's left is a 1. And then I can just combine and get a 4 over x plus 1. Pretty neat. That probably doesn't happen very often. So if that was the case, you would again just multiply by what they didn't have. This one had 2 x plus 1s. This one had 1 x plus 1. So they both had an x plus 1. I would have had to multiply this side by an x plus 1 on top and bottom, and this side by an x minus 1 on top and bottom. So that way you have all 3 factors down there. I think that's probably something that's going to happen here. So if I factored this, again, the first thing I could do is factor a 5 out. That's a 4x squared minus 1. I'm going to go ahead and cancel it with that 5 right there. For this one, I just know how that factors. This is 2x minus 1 and 2x minus 1. Again, I just knew those were perfect squares. This one, if you factor that, is 2x minus 1 and 2x plus 1. So again, in this case, both of these already have a 2x minus 1. Okay. The only way to make them the same is to multiply by what the other one doesn't have. So this one has 2x minus 1s. This one is going to need another one, top and bottom. This one has a 2x plus 1. It's going to need 1. Sorry, that work's looking pretty rough. So again, I already know my denominator, and I'm going to cheat just a little here too and say that that's 2x minus 1 squared times 2x plus 1. It's just to save me some writing room. And then I like to simplify the tops. So again, I have this 4 that's going to distribute through there. That's an 8x plus 4. When I distribute this x, I'm going to distribute a negative x, because this was a subtraction question, through here. So that's a negative 2x squared plus x. When you combine like terms, then this is a negative 2x squared plus 9x plus 4. Now, the bad part about this is this actually could factor a little bit more. First thing you're going to want to do is take the negative out. That leaves you with 2x squared minus 9x plus, minus 8, sorry. Is there something, if you, 4, minus 4. I was getting ahead of myself. And actually, I just lied to you, it doesn't factor anymore. I thought it did, but it doesn't. So I can finish that right there. I can either leave it like that. You could try to factor, this one doesn't. Like I said, sometimes they will. Or you could leave it like it was, the negative 2x squared plus 9x plus 4. So be sure you're paying attention to that, that your top potentially could factor out some more and simplify some things in the bottom. You just have to watch out for that.